Hey everyone, today we'll be going over LeetCode problem 704, binary search. In this problem, we are given an integer array called nums, and this is sorted in ascending order. We're also given an integer target, and what we want to do is find this target in nums, and if it exists, return the index of the target. If it does not exist, then we will return -1. And we must write an algorithm which runs in log n time. Now we know that because they're telling us the algorithm must run in log n time, we must implement this using binary search. And this is also given to us by the title itself. Binary search is the only searching algorithm which we know which can allow us to find a number in log n time. So I'm going to explain to you how this algorithm will work. We have here an example where our target is 9. And we have an array of 6 numbers, indexed from 0 to 5. We want to start off our algorithm by being able to consider all of the numbers in the nums array. And we will do that by having 2 pointers. We will have a left pointer and a right pointer. The left pointer will start at index 0, whereas the right pointer will start at index 5. And we are considering every number which goes from left to right. We will have a while loop. And this while loop will run until the left and right pointers do not cross each other. During each round in this while loop, we're going to calculate the midpoint between the left and the right pointers. So we know that, for example, in this case, we have left is equal to 0, and right is equal to 5. So 0 plus 5 divided by 2 is going to give us the midpoint. So we're going to do an integer division by 2, and we'd get 2.5, or 2. So what we would do is we'll have a third pointer, which will be our midpointer, and this midpointer will be initially positioned at 2. Now we're going to compare whatever number we have at the midpointer to our target. So we see 3 is what we have at the midpointer, and our target is 9. Now we know that 3 is not equal to 9, so we have not found our target. However, what we also see is that 3 is smaller than 9. And this information is very important for us. Because if we know that 3 is smaller than 9 and is not equal to our target, we can discard not only the 3, but every number which comes before the 3. In fact, this nums array, we are told, is sorted in ascending order. So if the 3, which is at our midpoint, is smaller than the 9, so will everything that comes before it in the array. So none of the numbers prior to the 3 will be matching to our target. Now, in order to represent this fact that we have discarded the first half of the array, what we need to do is simply move the left pointer to be equal to the midpointer plus 1. If instead the 3 had been found to be greater than our target, we would have moved our right pointer to be smaller than the midpointer. During the second round, once again, we would calculate our new midpoint. So this time we have left is equal to 3, and right is equal to 5. Dividing by 2, we have a midpoint of 4. So our midpointer would now be at the 9. We now compare whatever we have at our midpointer to our target, and we see that the 9 is equal to 9. Therefore, we have found our target. And so we would return the index of this 9, or 4, as our result. We now have a second case where our target is 2, and the nums array remains the same. So again, we would have our left and our right pointers, and we would calculate our midpoint. Once again, we would have initially 0 plus 5 divided by 2, which is equal to 2. So we'd have our midpoint initially at index 2. We see that 3 is greater than 2, so it is greater than our target. Therefore, to continue on, we know that we can discard everything from the 3 on, because the array is in ascending order. So if the 3 is greater than the target, so will everything that comes after. And therefore, what we will do is take our right pointer and make it equal to mid minus 1. Again, we would calculate our midpoint. So this time we have 0 plus 1 divided by 2, and that equals to 0. So our midpoint would now be the same as the left pointer. We would compare the -1 to our 2, and we see that this time the target is greater than whatever we have at our midpointer. So we can discard the -1 and everything that comes before the -1. However, there is nothing before the -1. So at this point, we would make our left pointer to be equal to the midpointer plus 1. Now the left and right pointer are at the same position, so when calculating our midpointer, it would be equal to 1 plus 1 divided by 2, and so it would also be at index 1. We compare our target to whatever we have at the midpointer, which is 0. We see our target is greater than 0, and so we need a greater number. Therefore, we can discard the 0 and everything that comes before it, and therefore we would move our left pointer to be equal to mid plus 1. At this point, we see that our left pointer is after our right pointer. So the left and right pointers have crossed each other. And this is when we would terminate our algorithm, and we would know that we have not found a target in the array. It does not exist in the array, and so we would return -1. So that was both the case of when we are able to find the target, and the case of when we are not able to find the target and return -1 instead. Now, why is it, however, that this algorithm runs in log n times? Well, let's consider, say we have a nums array where the length of nums is equal to 32, and this is equal to our n. So we know that during each round in our while loop until the pointers cross, what we do is we find the midpointer and compare this mid number to our target. We either find our target or see if the target is greater or smaller than this mid number. And by comparing, we are able to discard half of the numbers in the nums array. So in our worst case, if we never find the target in the array, we would go from having 32 numbers under consideration, we discard half and have 16 left. And once again, the 16 would be halved to 8, to 4, to 2, and to 1. So we see that each time, when comparing the target to the mid number, we're able to discard half of the numbers from consideration. Therefore, this while loop will run an amount of times which is equal to the amount of times that we can half our n, our size of the array, which in this case is 32. And we see that we're able to half it 1, 2, 3, 4, 5 times. Now, another way of saying the amount of times we can half 32 is the same as saying that we're taking the log in base 2 of 32, which is in fact equal to 5 because 2 to the 5th is equal to 32. And so as we can see in this case, our runtime was log in base 2 of 32, but the general case for any array would be that the time complexity would be log in base 2 of n. And before we move on to the code for this algorithm, I just wanted to make sure that it's clear, therefore, that in order to perform a binary search, we have as a requirement that the array must be sorted. So if we do not have a sorted array, we will not be able to perform a binary search on it. Luckily, in this problem, we're told that the array is sorted in ascending order. We're going to start off our algorithm by having our left and right pointers initialized to 0 and the last index in the array, so length of nums minus 1. And this algorithm is going to run until the left and right pointers do not cross each other. Each time we're going to calculate our midpoint, and this midpoint is going to be equal to the left plus right divided by 2. So we have found our mid-index. What we're going to do is compare the number at this mid-index to our target. If our target is smaller than whatever number we have found, then we know that we can discard the right half of the array because the numbers are in ascending order. Therefore, we can make our right pointer equal to the mid-pointer minus 1. In the second case instead, whatever number we have found at the mid-pointer is smaller than our target. So our target is actually greater, and we can discard the left half of the array. So we'll make our left pointer equal to mid plus 1. Our third case is instead that we have found this number that we are looking for, so we can return this mid index. If we ever finish this while loop without finding the number we are looking for, our target, we know that it does not exist in our nums array, and so we can return -1. Let's make sure this runs. And we see that it works efficiently. Thank you so much for watching this video. If you enjoyed it, please subscribe to my channel. I'll see you on the next one.